Hello students. In this video let us discuss about the second long answer question, important question from chapter 6, work energy power, that is state and prove law of conservation of energy. First let us write down the statement. Energy can neither be created nor destroyed, or total energy remains constant. Total energy means kinetic energy plus potential energy that must remain constant. If we can prove the total energy remains constant, then we proved law of conservation of energy. Okay. So now let us go for proof. Right. So for that, consider a body of mass m freely falling from height h. First point. Okay. Now this is ground. Right. From certain height h. Assume top of the building. Okay. Here. Assume top of the building. Okay. A body of mass m is falling down in such a way. Okay. It is a freely falling body. Freely falling body means the bodies which fall due to the gravitational pull of earth or gravitational force of attraction. Such bodies we call it as freely falling bodies. So a body of certain mass m freely falling from certain height h. Alright. Here we are considering 3 points or 3 positions. Alright. That 3 positions I mention with A, B, C. Suppose A, B, C. The first position I will take here top A. Then the second position B. And third position on ground C. Right? Suppose A, B, C are points at height. A is at height h. Right? Okay. Now B is at height. Okay. So B is at height. Let us assume as y. Okay. B is at height y. And C, it is on ground. Understood? From ground. We are calculating the height from ground. A is at height h. B is at height y. C is on the ground. Right? Okay. Now, consider first point A, then B, then C. And at each and every point, we will find the total energy. And if we can prove that at 3 points, this energy is same, then automatically we can say that law of conservation of energy has proven. Right? For that, first, I'm considering the point A. Okay? So, point A is the highest point. And at the highest point, initial speed, you will be 0. Here the initial speed will be 0 at highest point or at a peak at a certain height. The initial speed will be equal to 0. First, I'm writing kinetic energy. Right? Kinetic energy means half m velocity square. Here velocity or speed, initial speed we are taking. So I wrote u square. But u equal to 0, no? Half into 0 square, that is equal to 0 into something 0. Kinetic energy equal to 0. Next, potential energy. What is the formula for potential energy? Mass into acceleration due to gravity into height. That is m. Mass we are indicating with m. G. And what is the height of point A from the ground? H. Right? Now, total energy. Kinetic energy plus potential energy. E equal to total energy. What is kinetic energy? 0. What is potential energy? mgh. 0 plus mgh. At A, no, I will write at A. mgh. So, at point A, we got energy as mgh. Clear? Now, next, let us move to point B. So, a little bit mathematical part will be at point B only, but it is very easy to do. So, no need of worrying about that. Just listen carefully. Okay. Now, at point B. From ground, it is at height y. Now, body. Let us assume that. Body has reached point B. Okay. Let VB be its speed or velocity. Anything you write. It's up to you. Now from A, the body has reached to B. From A, the body has reached to B. Okay. This distance here I will draw the arrow. Y. Now here to here distance AB. I will write it as H minus Y. Did I write correctly? Yes, sir. Straight line, no. AC. No need of writing in exam, just for your idea I am saying. What we will write? AB plus BC. But I want AB, no. AB is equal to AC. This BC comes this side, becomes minus BC. So, what is AC? We said H. What is BC? We said Y. So, I wrote H minus Y. Correct only, no? No need of including in exam. Just if you understand, that's enough. How we wrote the displacement AB, if you understand, that's enough. Okay. Let V be its velocity. Right? Now, next, as usual, we are using the formula V square minus U square equal to 2AS. Alright. Now V. Final velocity. What I said now only VB. It reached to point B, no? So final velocity will be VB. So put VB in place of V. In initial velocity, as usual at highest point, 0. Acceleration due to gravity, in place of A, you put G. You will place G, right? The body is coming towards the earth. Okay, so plus G. Now next, in place of displacement, what is S? S will be equivalent to AB, that is nothing but the displacement of the body. So S is equal to what I will write? H minus Y. Right? H minus Y. Now put all this in this equation. In place of V, VB square. In place of U, 0. In place of A, G. In place of S, H minus Y. VB square minus 0, what we will get? VB square only. 2G H minus Y. Now what is the formula for kinetic energy? Half m VB square, because final velocity we are taking with VB. So half m, what you got VB square? 2G H minus Y. 2 strikes off. Clear? Okay. And now what we will get the kinetic energy? Kinetic energy is equal to mg h minus y. 2 strikes off. So mg h minus y. Or kinetic energy is equal to mg, multiplying, I am multiplying into h. In between minus sign is there. I am keeping mg into y. Mg y. Right? Now let us write potential energy. I will write mg, height no. See, our point B is at height y. The main thing you have to remember, when it is coming, when we are talking from top to bottom, we are talking about displacement. And when we are talking about the height, we are considering from the ground. So height of B from ground is y. So what I will write? mg y. So total energy, kinetic energy plus potential energy. What is kinetic energy? mgh minus mgy, this one. Now what is potential energy? mgy plus mgy minus mgy strikes. So total energy I will write at point B, no? EB is equal to what remained? mg h. Now this is at point B. Clear? Right? It is easy mathematical part. No need of worrying. Now let's at point C. So assume body reached point C. Right? Point C. Now next, velocity of body while reaching from A to C. Assume as VC. Okay. As usual, we will use V square minus U square equal to 2AS formula. If you practice B perfectly, C will be very easy to write down. Okay. So, in place of V, final velocity VC. In place of U, as usual, initial speed 0 at maximum height. In place of A, as usual, G, freely falling body, acceleration due to gravity. And in place of S, what I have to substitute? Now let us see the diagram. Body has reached from A, it has reached to C. How much distance it has displaced from A to C? How much it has traveled? Can I say H distance it has traveled? The height of point A from ground, I said h. Now from A, it has reached point C, I am saying. So I can say no, that a body has traveled h distance from A to C. A to C, it has traveled h distance. So h. Now substitute in place of V, Vc square. In place of U, 0, 0 square. 2G in place of S, displacement. S is nothing but equivalent to AC, which we call it as displacement. Right? Which we call it as displacement. Clear? So, Vc square 2GH. Next, what we will do? We will substitute in kinetic energy formula. Now here I am writing Vc square, because we assumed velocity as Vc when it reached the point C, which is on the ground. Okay. So, half m, what is Vc square? 2G H. 2 strikes off. mgh. Now next, potential energy. Mass into acceleration due to gravity into height. Right? Now what will be the height? Can you say what will be the height? Point C is on the ground. Height will be 0 because it is on the ground. So height will be 0 because it is on the ground. Right? So potential energy is 0. Next, what you will write? Total energy. Kinetic energy plus potential energy. Total energy at point C, no, EC, I will write. What is kinetic energy? mgh plus what is potential energy? 0. So EC is equal to mgh. Now see, EC, mgh. EB, mgh. EA, mgh. So can I write? EA is equal to EB is equal to EC is equal to mgh. That is, the total energy is same, that we call it as constant, hence proved. This is about law of conservation of energy. So thank you for watching my video. If you like it, share it, subscribe it. Thank you, yours Reshma Physics.